The next chapter is called naive Bayes, and naive Bayes is a data-driven approach, which means there is no underlying model like in a regression model. So it's a non-parametric, like descriptive statistics type of methodology. It makes no assumptions about the data like normal distribution or skewed or not skewed. None of that matters. So the basic principle is that for each record to be classified, so we call that a predictor profile. Predictor profile is a set of values for the x variables, for the predictor variables. So when you have a predictor profile, so you find the records that match the predicted profile within each class and compute um, joint probabilities and conditional probabilities and come up with propensity for each class. So that's kind of a general outline of the methodology. So what we're going to do is we're going to start with basic probability concepts, and we'll look at Bayes theorem, and then we will apply Bayes theorem as is in a simple small example. So that will be called exact Bayes, but there are some problems with exact Bayes. Computationally it is not very efficient and there are some issues. Therefore we will be using what is called naive Bayes, which makes a couple of assumptions to make the computations simpler. So that's the outline of what we're going to discuss. So let's start with basic probability. So probability of an event, okay. So basic probability is a numerical statement about the likelihood of an event, and that numerical statement should follow two rules. It should be a number between 0 and 1. So that will be the probability of an outcome being between 0 and 1. Closer to 1 means it's more likely to happen. Closer to 0 means less likely to happen. And if you look at all the possible outcomes, okay, and each outcome having a particular probability associated with that, then if you sum all those probabilities for all possible outcomes, then you should get 1. Okay. So for example, if you toss a coin, there are two possible outcomes, heads or tails, and you associate probabilities for heads and probability for tail, and when you add the two probabilities, it should be equal to 1 because those are the only two possibilities. And another example for a die will be there are 6 faces to a die. So you have 6 possible outcomes and you assign probabilities for each one of them. So each probability must be a value between 0 and 1. And when you add the 6 probabilities, it should be equal to 1. Of course, if it is a fair die, then each outcome will be equally likely. So therefore, each probability will be 1, 6, 1, 6, 1, 6, 1, 6, 6 times, and all add up to 1. And in the case of a toss of a coin, if it is a fair coin, then it will be 50-50, 0.5, 0.5, adding up to 1. So that's the basic rule for probability. And now we define an event and then find the probability of an event. So an event is list of one or more outcomes. So for example, in a roll of a die, suppose you define an even number. So that would mean when you roll a die, you get either a 2 or a 4 or a 6. So 3 possible outcomes will define that event. So the probability of an event is then given by the number of occurrences in the event, okay, number of ways in which the event can happen. So if the event is even number on a roll of a die, and there are 3 ways in which you can get that outcome. So divide by the total number of possibilities. So there are 6 possibilities, out of which 3 will define the event. So you get 3 over 6 equal to 0.5. So that's probability of an event. Okay. Now let's look at a definition of what is called joint probability. Suppose if you have 2 different events, right? So you have A, and then you have a probability of A, and then you have B, event B and probability of that event occurring. Now the joint probability A and B is defined as the probability that both A and B will be true. So in a Venn diagram you can see that by, so if this circle represents probability of A and this circle represents probability of B, then this common area is where both A and B are true. So that probability is called joint probability, A and B. Then we can define other probabilities such as probability of union of events. So you have two events A and B, and what is the probability that either A or B is true? So that is either or is union, so A or B. So that probability can be computed by taking probability of A and adding probability of B to it. Okay, A plus B. But when you do that, what happens is that this part gets added twice. So you need to subtract probability of A and B, then you get probability of A union B. So we will look at numerical examples of these in Excel.